Hey everyone, this is completing the square day one. Here we are. Here's the title right up here, day one. The reason why I have day one there is because completing the square is something we're going to be doing for the next couple of days, or rather the next couple of lessons. And each day completing the square will build off the previous day. So it's really important that we nail this method down today so that the next time or the next day or the next lesson we revisit completing the square, we'll have a great foundation already laid for us. So our learning goal today is we're going to learn how to complete the square. Yeah, complete the square right here. And what this will do for us is it'll change quadratics that are in standard form into vertex form. So standard form being the y equals ax squared plus bx plus c. That's standard form. And then vertex form, remember that? Vertex form is y equals a bracket x minus h squared plus k. That's a k. Okay. Lovely. Now, up until this point, it says here, recall. It says here, find the vertex of the parabola described by this equation. And here's the equation we have. It's in standard form, and we know that because well, it kind of looks like it, but also because it's a trinomial here. Ax squared plus bx plus c. It wants us to find the vertex of this parabola. And up until this point, the only way we kind of know how to find that vertex would be following these five steps. So the first step here would be to factor this equation. So when we factor it, now this is going back here, we're reaching into our big bag of tricks of factoring. We draw that magic X, and our AC value, our A value is 1, our C value is 40, so 1 times 40 is 40, of course, and then 14. So we're looking for two numbers that multiply to 40 and add to 14. So I think those two numbers would be 4 and 10, right? And then at this point we divided each one of these by the A value, which would be divided by 1. Now this step is kind of redundant because if you could recognize this is a simple trinomial, and at this point you're like, why are you dividing by 1? Well, hold on here. Don't forget that the magic X will work for these simple trinomials as well as the complex trinomials. I know it's been a little while. So the first factor here would be x plus 4, right? 1x plus 4, or rather just x plus 4, and then the other one would be x plus 10, and that's how we factor that. Now, if we want to solve these as x-intercepts or as zeros, what we do is we take each of the factors and we set them equal to 0. So for example, in this first one, we grabbed x plus 4 and we set it equal to 0. Right? You see that there. And then we just solve for x, just like we did maybe in grade 9. We bring that plus 4 over. Right? This plus 4 comes over here, and we get negative 4. We're not surprised by that. Same thing with the other factor, x plus 10 equals 0. Bring that positive 10 over here, and we get negative 10. So these are our two x-intercepts. Now someone might ask, hey, Mr. Yakimishin, if this was x minus 4, right? If it was x minus 4 equals 0, and it came over, would it be x equals positive 4? And that answer is absolutely it would be. But in this case, it is x plus 4. So you got to remember when you got to take away 4 from each side, or maybe bring it over. However your brain kind of looks at these types of things. Yes. Next, because these are the two x-intercepts, one at negative 4 and one at negative 10, they are, and it's a parabola here, we know that these two coordinates are symmetrical, meaning there is a line of symmetry that exists between them. So in order to get that line of symmetry, oh wait, I forgot we're in grade 10, axis of symmetry, yeah, fancy words here. What we're going to do is we're going to add the two x-intercepts together. So we're going to do negative 4 plus negative 10, and then divide it by 2. And that's taking the average, and that'll give us the middle. So the middle of negative 4 and negative 10 is negative 7. Lovely. And if you remember, I mean, this is a big stretch, but I remember planting little seeds along the way, even from Unit 3. The axis of symmetry is actually the x value in the vertex. Remember that? Meaning, we know that the vertex always, always, always lies on the axis of symmetry. So that's kind of half our vertex done. And to get the other half of it, we're going to take this -7 and we're going to plug it into that original quadratic right in there. And again, use a calculator. Just be careful. Here we go. And we got -9. Great. So our vertex would be -7, -9. That's the vertex. Now this is quite a lengthy process, and if you're wondering, is there an easier way? There is absolutely an easier way, and that's completing the square. Completing the square will bring us from this standard form right into vertex form in just a few lines of math. So before we actually get into there, let's keep remembering some important things here. Let's have a look here. It says we need another way to determine the vertex. We do have a method. It's called completing the square, and we are going to love this, I promise. It wants us to factor these. Now, it's been a little while. Okay, here we go. It's a simple trinomial. So we're looking for two numbers that multiply. This is a 1 here, so 1 times 9, multiplies to 9 and adds to 6. Yeah? I think that would be 3 and 3, right? 3 and 3. So when we factor that, we'll say, okay, that equals x plus 3, x plus 3, right? Remember that? And then we can actually condense that even further and just say, okay, well, that's x plus 3 squared. Not bad. How about this next one here? Oh, again, it's a simple trinomial. That a value is 1. So multiplies to 36, adds to -12. I'm thinking maybe -6 and -6. Yeah, I think that works. So we will write that as factors, x minus 6, x minus 6, and we get x minus 6 squared. Interesting. Lastly, we got multiplies to 25 and adds to -10. And this one's going to be -5 and -5. Yeah, because add them together, you get -10. You multiply two negatives, you get a positive 25. Absolutely. So these factors would be x minus 5, x minus 5. And again, this will condense nicely or simplify nicely into x minus 5 squared, right? Because x minus 5 times x minus 5 is really like saying x minus 5 times itself, which is squared. Okay. What do you notice about each of the three of these? Maybe we should even write that out. What do you notice? What do we notice about all of these things? Well, first of all, each of these quadratics, or each of these, these questions here, the things that we have to factor, these quadratics, these trinomials, they are all simple trinomials, meaning they each have an a value that is set to 1. Now that's great. That's cool. But if you look at the end result here, they all end up being something times itself, meaning x plus 3 times x plus 3, which gives us x plus 3 squared. So they all end up being squared at the end. And that is by no coincidence at all. In fact, this is called a perfect square, right? When a trinomial factors into a wonderful factor times itself, right? Like all three of these do, it's called a perfect square. It says here, notice that all of the trinomials we just factored were perfect square trinomials. Yeah, would you look at it? And then there's a whole bunch of stuff written here, which is lovely. If you're a pattern person and you love to see the patterns, this is for you. But basically what I'm trying to say here is that, okay, you start off with 1x squared, or just x squared, plus bx, like any number here, and plus c. And it factored into x plus something squared. That was the end result. Or hold on here. It was minus bx and therefore you got minus something squared. Okay, now that's what this first line means, and you're not surprised by that because we just kind of talked about that. Now, what is super duper important, or maybe not so important, but really, really cool, is that if you notice this b value here, actually all the b values, but let's have a look at this first one. Every single b value, right, this one's 6, it ended up being half of 6 in the brackets squared. So like x plus 3 squared. And if you look at the negative 12, it ended up being x minus 6 squared. Interesting. If you look at the minus 10, it ended up being x minus 5 squared. Right? Just half of whatever b is. And that's what I'm trying to say here. I'm like, hey, look at this pattern that you might find here. If it was x squared plus bx plus c, yeah, you'll get x plus b divided by 2 squared. Like whatever that b value is, just divide it by 2. And that's super important. Or rather, I keep saying important, but it's just a really, really cool trick. You're going to see how that trick kind of comes in handy here. The last thing to notice, well, how do we know when a perfect square trinomial is in fact a perfect square trinomial? Well, here's how we know. We have a look at the b and c values. It says here on the previous slide, it says they all had an a value of 1. Yes, we know. And then, this is important, I'm going to pull up my highlighter. The c value was half the b value squared. Now that sounds a little strange, but here's what it's talking about. Let's go back here. This b value, this 6, right? If we take the number 6, divide it by 2, that's a 2, I promise, 2, and square it, we should get 9. So let's go ahead and say, okay, well, this is now 3 squared, and 3 squared is 9. So yeah, the c value is half of the b value squared. Yeah? So let's look at the second one here, negative 12. So we'll do negative 12 divided by 2 squared. Let's have a look. Negative 12 divided by 2 is negative 6 squared, and we end up getting 36. Okay, interesting. So that works out great. These are all perfect squares trinomials. So let's look at this one, negative 10. We can do negative 10 divided by 2 is negative 5. Negative 5 squared is positive 25. So that's kind of how you understand where and when a perfect square trinomial can come about. So just for today, when we're completing the square, we need our trinomials to be perfect square trinomials and the a value to be set to 1, okay, in order for us to be able to complete the square. Now, new example here. Let's kind of cut this page in half. Let's say we had something like, okay, x squared plus 12x plus something, and there's a blank there. It says here, what would we need to add to the equation so that it could be factored into a binomial squared, like something plus, x plus something squared? Well, what we're going to have to do is take this b value, which is 12, and we're going to divide it by 2 and square it. So let's go ahead and, here, actually, I think I got it. Yeah. 12 divided by 2 squared, which gives us here, whoops, 6 squared, and 6 squared is 36. So if we want this trinomial to be a perfect square trinomial, what we're going to have to do is add 36 at the end there. If we want this to be a perfect, so we can go ahead and even write that in here. It's got to be plus 36. Now, you could think to yourself, okay, well, what are two numbers that multiply to 36 and add to 12? Well, you can go ahead and draw that x if you want, like 36 and 12, absolutely. But what you're going to learn quickly is that, these two numbers, I know you're really good at finding them, but also, because it's a perfect square trinomial, we can just take half of the b value and throw it in the bracket squared, right? We know it's going to be x plus 6 squared, right? Like we totally can see that. Like this is going to be x plus 6 and x plus 6, which inevitably gives us x plus 6 squared. Or you can just use that little shortcut, identify that this is a perfect square trinomial, and just throw it in brackets, half of the b value right there, and Bob's your uncle. It's great. Okay, let's try one more. So let's try this one. What would we need to add to the equation so that it could be factored into a binomial squared? X plus something squared, or x minus something squared, whatever it is. So, x squared minus 8x plus something, we want it to be a perfect square trinomial so that it factors into a lovely perfect square. Well, we know that if we want to make this a perfect square trinomial, then we're going to have to take that b value, divide it by 2, and square it, and that result will be the c value that'll make this factor wonderfully. So the b value here is negative 8. So we're going to say, okay, negative 8 divided by 2 squared. And notice how I have the brackets around here. I think it's pretty important because when you're dealing with negatives and things like that, you're going to see how it'll come in handy. Negative 8 divided by 2 is negative 4 squared. Now, this is where the brackets come in handy because we are squaring the 4 and the negative. So this result should be a positive outcome. So it's going to be a positive 16. So that means that if we wanted this to be a perfect square, this c value has to be 16. And again, you could draw out the magic x. You really could. Two numbers that multiply to 16 and add to negative 8, right? You know it's negative 4 and negative 4. You can do all that. But because this is a perfect square trinomial, you could just take, okay, negative 8x, half that is negative 4. So x minus 4 squared, just like that. Now, if at this point, if you're okay with this stuff, then we're going to move on. If not, maybe you can even go back a little bit, maybe rewatch some of this stuff, or maybe even ask me a question at this point. But if you're all good, we are going to move on. It says here, okay, so technically, we can't just add a number onto this equation here. Like, we can't just do that. We can't just add 16 over there. That breaks a ton of the math rules, because remember in math, we're like, hey, whatever you do to one side, you have to do to the other side, right? And the reason for that is because if we don't do anything to the other side, then it changes the whole thing. But if we both add and subtract a number, right, then really all we add to the equation is 0. So really, if you add a number in, like let's say you add 16, and then you take away 16, really what you did on that side was nothing, because 16 and take away 16 is just 0. So doing nothing to one side, you don't have to do anything to the other side. And that is one of the coolest moves here in, I think, in quadratics. So let's try it with this question. So we have here y equals x squared plus 4x plus 21. Okay, notice how this this trinomial is not a perfect square trinomial. Unfortunately, it's not. Now, if it were, I know it says here, note that 21 is not half of b squared. It's not, we're a little upset about that. So we need to find a number that can add and subtract to make a perfect square trinomial. So check this out. What do we really want this c value to be? What do we really want it to be? Well, we're going to take that b value, which is 4. We're going to divide it by 2 and square it. 4 divided by 2 squared, which gives us 2 squared, which gives us 4. So if it were x squared plus 4x plus 4, life would be great. But unfortunately, it's plus 21. Now here's one of the best moves in quadratics. Here it goes. What we're going to do is move this 21 a little bit over. And we're going to add 4. We're going to add 4 and also take away 4. Right? You see that? See what we did there? We added 4 and took away 4 because that's really nothing, right? That's 0. So that means we don't have to do anything on the other side of the equation because we really didn't do anything on the right side. We added 4 but also took it away, which is like doing nothing. Best move. I love that move. And here's why I love that move. Now let's have a look at the first 3 terms. Look at this. The first 3 terms are a perfect square trinomial. So let's go ahead and factor just the first 3 terms. Again, looking up here, we have a perfect square trinomial. We can put it in brackets squared with whatever half the b value is. So it's going to be, this one's the b value of 4. So this is going to be x plus 2 squared, right? So this trinomial right here is now this binomial squared. Notice how we didn't touch the minus 4 just yet, right? It's still there. And same with the plus 21. It's still there. All we have to do now is kind of just collect our like terms or kind of just clean up that tail end there. Negative 4 plus 21 can simplify nicely into positive 17 at the end there. So there you have it. So we have here y equals x plus 2 squared plus 17. Folks, that is it. That's completing the square. And if you look closely at this last line here, this is in vertex form. Look, the vertex, I guess, would be negative 2, positive 17, right? Now, I say negative 2 because remember, x plus 2, it's really a negative 2 in disguise. Remember that? So yeah, that's our vertex, and there you have it. That's pretty much it. That's completing the square. It's such a great move. Like, if you look at that first page of this lesson compared to these, 1, 2, 3 steps, how great is that? Okay. It says you've just completed the square. The process of adding and subtracting a constant to a given quadratic expression to form a perfect square trinomial is probably the best move in math. I love it. I love it. It is also the process that converts a quadratic from standard form to vertex form, and this is great information. Now, if you are a steps person and you want to follow the steps, this is for you, right here. First of all, you're going to take half the b value and square it, right? And you get a number, right? You get a number. Now, what you're going to do is you're going to add the number and also subtract the number in your trinomial. You're going to factor the completed square trinomial. Lovely. You are going to collect your like terms at the very end there, and there you have it. You should have a x minus h squared plus k. It's going to be in vertex form, just like the other one. Okay, you know what? Let's try another example. Write each equation in vertex form by completing the square. Okay, so let's go ahead and do that. And then it wants us to do this. It wants us to identify the coordinates of the vertex. It wants us to find the equation of the axis of symmetry, tell us whether it opens up or down, and then the max or min value and when it occurs. All right. So we have here y equals x squared plus 12x plus 14. Now, if you look, it's like, well, this is not a perfect square trinomial. It's not, because 14 is not half of the b value squared. In fact, what do we want the c value to be here? Let's go ahead and complete the square. So this 12, let's think about it. We're going to take this 12 and we're going to divide it by 2 and square it. So we should get something like 6 squared, which gives us 36. So it would be really ideal if it was x squared plus 12x plus 36, wouldn't it? So that's what we're going to go ahead and do. We're going to complete the square. Whoops. Let's move this over a bit. We're going to take this 36 from the right-hand side here. We're going to add it in, but also take it away, right? Because we don't want to break any math rules here. So we add 36, take away 36, and that plus 14 is still at the tail end. No problem. Now, the first three terms right here, x squared, these first three, this is a perfect square trinomial, so we're going to go ahead and factor it, and it's going to factor into x plus 6 squared, right? And you're going to get really fast at that. Now the minus 36 we haven't touched yet, and the plus 14 we haven't touched yet. We can go to our calculator and clean up the tail end there. So we should get negative 22 at the end. So yeah, y equals x plus 6 squared minus 22. That is completing the square, just like that in 3 steps. So now it wants us to identify the coordinates of the vertex, which should be negative 6, negative 22. The equation of the axis of symmetry should be x equals negative 6, right? Because it's just the, yeah, let's go ahead and do that. Vertex for sure, we're really good at that. The axis of symmetry is just the x coordinate of the vertex, or rather the h value. This is h and k, right? This, of course, opens up because I know there's no a value here. Like, there's nothing out front, but we assume that it's a positive 1 out front of the bracket. So let's say the a value is set to 1, which we know that it is from the original, quadratic here. And the max or min value, now because this thing is opening up, it's a minimum value of negative 22, and this occurs at x equals negative 6. Okay, the next one. We have your y equals x squared minus 10x minus 22. Minus 22 does not feel right. It should not be minus 22. You might be able to already do this step in your head to figure out what that number might be. So we know it's that c value. If we want to make this a perfect square, we're going to have to complete the square. So we're going to have to take the b value, take half of it, and square it. So negative 10 divided by 2 squared, we should get negative 5 squared equals 25. So what we're going to do with this 25 is that we're going to add it into the equation and also subtract it because we don't want to break any math rules. It goes, I like to put it there strategically, of course. I put it right in between the b and the c value because, well, check this out. The first 3 terms factor into a perfect square. So we're going to get x minus 5 squared, right? Minus 25, we haven't touched it. Minus 22. We haven't touched that either. But now we're going to go ahead and clean it up at the tail end there, and we should get a negative 47. So y equals x minus 5 squared minus 47. Great. So what is our vertex? It should be positive 5, negative 47. Here, let's go ahead and just... The axis, the axis of symmetry occurs at x equals positive 5. Of course, this one opens up. In fact, I think they might all open up today because all of the a values are set to 1. And we'll say a minimum value of negative 47, and that occurs at x equals positive 5. And again, this should be kind of familiar from the previous unit. But yeah, but this completing the square stuff, super good, super helpful. Okay. Now, another great reason to be able to complete the square is because we're able to graph quadratics so much easier than making a giant table of values. So for example, graph by completing the square, no problem. Here we go. Well, x squared minus 6x plus 7, we don't really want plus 7. What we really want is half of b squared. So half of b squared, so negative 6 divided by 2, sorry for the penmanship, squared. We should get negative 3 squared. Where's my equal signs? And we should get positive 9. So we're going to take that positive 9. We're going to add 9 and also take away 9, right? We don't want to break any math rules, okay? And then the first 3 terms factor lovely into x minus 3 squared, minus 9 plus 7, and the minus 9 plus 7 very quickly goes to the negative 2 at the very end there. Great. So if we wanted to graph a quadratic, well, what we can do is first grab the vertex. So what's our vertex here? Our vertex is positive 3, negative 2. Okay, lovely. And then our step pattern, SP, right? Remember it was 1A, right? 3A, 5A, dot, 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 7A, 9A, and so on. But 1, 3, and 5 are great. The A value is just 1. So we're going to sub in 1, which for some of you are probably like, this is a little redundant. I know, but showing my work here. And we should have here, whoops. 1 times 1 is 1. 3 times 1 is 3. 5 times 1 is 5. So the step pattern is just 1, 3, 5. So we're going to start at the vertex, which is positive 3, negative 2. There it is. And now we're going to step pattern. Over 1, up 1. Over 1, up 3. Right? 1, 2, 3. Over 1, up 5. 1, 2, 3, 4, 5. And the same can occur on the other side. Left 1, up 1. Left 1, up 1, 2, 3. Left 1, up 1, 2, 3, 4, 5. Hey, look at that. And I'm going to attempt a smooth curve here, but I know it's going to be horrible with the mouse. Oh, not bad. Okay, I expected much worse. Great. It's a little funky, but I think you get the point. Don't forget that we could still graph quadratics by using the vertex and the step pattern. Again, that's something that we kind of used in the previous unit, and it's really, really evident here. Okay. Now, some of us might have been wondering this along the way. Well, what if it's a nasty number? So how about this? Complete the square. Y equals x squared plus 3x plus 1. Okay. This plus 1 is not something that we want. In fact, we want whatever half of b squared is. So half of b squared, 3 is the b value. So we're going to take 3, divide it by 2, and square it. And this is what I mean by nasty numbers. So 3 divided by 2 is 1.5 squared. And if we take 1.5 and square it in my calculator, we should get 2.25. Okay, 2.25. Kind of nasty, but that is the number that we want to add and then subtract. So here we go. We have our original quadratic here. We're going to add 2.25 and then subtract 2.25 because we don't want to break any rules. There we have it. Now the first 3 factor into a perfect square, a binomial squared. So, this is a little nasty, isn't it? Right? What are 2 numbers that multiply to 2.25? Okay, but also add to 3, and this probably feels a little bit weird to add to a larger number than what you're multiplying to, right? Like, it's super weird. But just remember, there's a beautiful trick to this. That's why we take that, whatever the b value is, right? Half of the b value is 1.5. So it's going to be x plus 1.5 squared, right? Minus 2.25 plus 1. We haven't touched it. And that's the whole beauty of the trick here, right? Of just taking the half the b value and throwing it within the brackets there, squared. The reason for that is, well, one, it saves us a lot of thinking power right there. If we just identify that little pattern. But hey, we could draw the magic X, 2 numbers, multiplies to, 2.25, adds to positive 3. Sure, you totally could do that. Then we'll clean up the tail end. Here we have it. So yeah, even with nasty numbers, it's nothing crazy even with nasty numbers. So again, if you're the steps person, this is for you, right? This is right here. You can almost use this as a guide to completing all these questions. Steps to completing the square when a is 1. You take half the b value and square it. Then you're going to add and subtract the number found in part 1 after the b term, right? So you're going to after the 3, which is the b term, plus that number minus that number. Great. Factor the first 3 terms into a binomial squared. Lovely. And to get that k value, which is at the very end here, the negative 1.25, you're just going to simplify whatever these are here, right? You're just going to simplify these guys. Great. And I think you got it. So, folks, I need you to get good at this. I need you to. And I know you will. I know you will get good at it really, really quickly. If not, you're already pros. Homework here's on page 331. I have here 1A, 2, all of number 2, yep. 3A for sure. I'm having a look at it right now. That's why I'm talking out loud. Sorry, I do not want 3A, actually. I do not want that. I want 5A, 6A, 7AB, and then there's a worksheet here. Now, the worksheet, it's going to come with solutions, but it's just to, again, practice completing the square, because the next day it's going to build a little bit, so it's important that we nail this one down before we move on. Okay, so I'm going to briefly go through each of these slides in case you maybe wanted to pause on one of them. But other than that, folks, please feel free to let me know if you have any questions at all. Instead of doing all of this work here, folks, we can just complete the square, 3 steps, and get the vertex just like that. If you need anything, let me know. I'm always here for you. But let's start completing the square.